In this tutorial, we are going to learn all the concept of git commands, installation, and the configuration with the remote repositories, an actual example with the Bitbucket and GitHub. So let's get started. Please subscribe, like, and hit the bell icon to get the instant notification when I upload new tutorials. What is Git and why it is so popular? Now, if you're someone who is new to programming or is still using an old version control system like CVS or SVN, then this tutorial is for you. Those who are new to programming might be wondering what is version control and why do we need this? Actually, the version control system keeps the track of every modification to the code and save it to a special kind of database called repository. Repository not only saves the code but also records the entry information like date of code change and the developer who made the changes and the reason why it was changed and some other more internal information. Let's say you don't want to use the version control system. As a developer 1, you are keeping 3 versions of code in your local system. So you are keeping multiple copy of the same code with minimal changes in different versions. And then it becomes more complex when you have a multiple developers in a team. Then it is nearly impossible to sync up the code, which leads to unnecessary bugs while merging the code. With version control system, we can track the history of the code changes and it is easier to work together in a team. There are 2 types of version control, centralized and distributed. Centralized control versions are based on the idea that there is a single central copy of your project somewhere on the server and programmer will do their changes on this central copy. So centralized version control solves the problem of keeping many copies of a files on a drive manually, like CVS or SVN are the example of centralized version control. In 2005, the idea of distributed version control became popular. So in this each developer clones a copy of a repository and has a full history of the project on their local drives. This may seem to be redundant and wasteful, but in reality it is not. Most of the code files are text files, which are very small in size, and gives a full control to each developer to work separately on their piece of code, and later it can be merged into the remote repo. Most popular version control systems are Git, Mercurial, and Bazaar. Out of these, Git is the most popular version control system, and we are going to work on Git. So why Git is so popular? Git is a free open source distribution version control system designed to handle everything from small to very large projects with speed and efficiency. It also handles your security with cryptographic method SHA-1. This algorithm manages your versions, files, and directory securely so that your work is not corrupted at all. Git is created by Linus Torvald, the man who developed and wrote the Linux operating system. The very next question comes into your mind, why should we learn Git, right? So almost all the organizations in the whole world are using Git as their version control system. Suppose if you are looking for a job in a software development, then you must know it. It is very likely that in each job description of a developer, it includes Git no matter what technology or language you are working on. So how do we picture Git in a whole sum? At very first layer, we have our working directory and you can say your workspace. So once you are done making changes, you add the code files in Git, which is basically placing the code files in a staging area. So once your code changes are in a staging area, then you commit your changes by writing some comment so that later you know why did you make those changes. It is kind of a hint. After commenting your changes, these will be recorded or saved in a local repository with some hash address to be unique. Finally, when you are ready to push your changes in remote repository, then you push your changes and now we have your changes in a remote repository. Other developers can see your code now. When other developers want latest codes from the remote, they can just use pull to bring the latest code in their local repository. And from there, it will be pulled all the way to the developer working directory, or you can say workspace. All these 3 steps are at local system, or you can say at a developer local machine. And a remote system could be on a server or any Git provider. Main prominent Git providers of remote repositories are GitHub, Bitbucket, and GitLab, out of which we are going to see GitHub and Bitbucket. So at first we are going to discuss about Git at local system, and then we will see about a remote repository as well. To work on a Git at local system level, you need to install the Git in your system first. You can directly go to the git-scm URL and download the Git setup and install it. Or you can go to Google and search for Git download and click the first link of git-scm.com. Here you got option to download Git for Mac OS, Windows, Linux operating system. For me it is Windows, so it is showing download right here. Let me download it. Once downloaded, install it and open the Git bash in your machine. It will look something like this. Now type git version and enter. Bingo. If you see the Git version, then Git is installed. For Linux operating system, you can install the Git by running these three commands: update the package, install the Git, and verify the Git version. If Git version comes up, then Git is installed. For Mac operating system, you can install brew first. If it is not already installed, then install Git with brew and verify the Git version. This is command line interface for Git operations. Do we have any GUI tools for Git? Oh yeah, we do have many, and there are some of the examples: Git Kraken, Source Tree, Tortoise Git, and Git UI. Git UI is already installed with the Git setup. Let's go to git-scm, and here click on this GUI option. Here we have third-party GUI tools. We have Source Tree. This is available only for Mac and Windows. We also do have GitHub Desktop for Mac and Windows. Tortoise Git is only available for Windows. Now here we have a winner, Git Kraken. This works on all the three operating systems: Linux, Mac, and Windows. And we have other options you can go through. Here you can check for specific OS, for Android and iOS as well. Why do we need to learn CLI if we have GUI tools, right? If you know CLI, then it will help in your technical interviews to answer the Git command questions, and certainly they are not going to ask about the GUI tools. And also, if you end up in a project or company where GUI tools are not available, which is the case actually, then CLI is your only friend, which will help you in all the cases. Git have three levels of configuration. First one is system. System level configuration is applicable across the entire machine, which covers all the users of operating system and all the Git repos. Next is global configuration. Global configuration is user specific, and it applies to an specific operating system user. Now, the local configuration is very specific, and is specific to a particular Git repo. Order of priority of configuration levels are like this: system, global, then local. Local have the highest priority. Enough for the theory. Let's do the Git configuration and start with the commands. Open Git with the administrative permissions. In case of Mac and Linux, configuration should be with sudo command. So we have opened the Git CLI. Let's start with the system level configuration. Git config -- system user dot name, and in the double quotes dev space sys. Because of the space, we kept the name in double quotes. Enter. The next command will be git config -- system user dot email. So sukuncode@gmail.com. Let's check system level configuration now. Git config -- system -- list. You can see user.name and user.email is being set. Let me clear the screen. Clear, enter. You can also check a specific configured element like git config hyphen system user.name, enter. Here you can see dev sys, use upward arrow, last ran command will appear, edit it, user.email. Now you can see the email address. Now to check all the properties of system level configuration, you can use show origin command. Use upward arrow. Here we will edit the command list show origin. Enter. You can see all the configuration of system level here. Let's do the global level configuration now. Git config global user.name double quotes dev space global. Enter. Use upward arrow. Now change this command from user.name to user.email. Type your email here. Enter. Now to check the global level configuration, you will type git config global list. As we can see, user.email and user.name has been set. Let me clear the terminal. Clear, enter. Let's do the local level configuration now. Git config local user.name double quotes dev space local double quotes. Enter. Oh, we see an error. You know why? Because we discussed earlier that local level is specific to a repository. So for that, first we need to create a repository, or in terms of Git, that we need to initialize a repository. So I'm choosing some place to create the repository for this. I'm going to D drive. Inside D, mkdir-p. So I'm going to create a new repository called repositories. Inside this, I'm going to create local repository. That's it. Enter. Let me clear this. Let's type cd repositories local repository. All right. Let's check local repository is blank or not. So it is blank. Now let's create or initialize the Git repo here. Type git init, enter. Initialized empty Git repository here. Let's check what is inside this repository. So .git folder has been created, and as you can see, the local repository branch name has been mentioning here as master. So by default the branch name is master. Let's continue with the local level configuration now. Git config local user.name double quotes developer space 1 double quotes. Same manner we'll set git config local user.email sukoondeveloper@gmail.com. Let's check the configuration now. Git config local list. So as we can see, the username and email has been set. We can also check a specific configured element also. Git config local user.name, so developer1. Same manner, use upward key and change user.name to user.email. So you can see sukoondeveloper@gmail.com is there. Vim is a default editor for Git, but Git allows you to change your default editor by setting core.editor setting. In Mac OS, you can set the Emac as your default editor by running this command. In Linux, you can choose Nano as your default editor and run this command. In a similar way, for Windows, you can configure Node++ as your default editor by setting the core.editor like this. If you are programming on a Windows operating system and other developers work on a different operating system, you might get into a line ending conversion issue. This is because Windows use 2 character for new line, carriage plus line feed character, while as the Linux and Mac use only line feed character, which is 1. So to fix this issue, you should set these 2 properties on Windows machine. When you get the code from remote repository, line feed character will be converted into Windows CRLF if core.autocrlf is true. And by setting the input on Windows machine, we'll convert the CRLF to line feed corrector before pushing your code to the remote repository. These configurations are more than enough to start with the Git. If there are any other configuration will be needed, we will set on the fly. Let's jump into the commands which we are going to use on daily basis while working on any project. Currently our repository is empty, so I'm adding few files here. Consider this current directory as your working directory, or you can say your workspace. Let's create our first file by using the Linux cat command. Cat greater than symbol file name as simple text file 1.txt. Enter. You can write some text here. This is a simple text file, comma, text is okay. Press Ctrl D or Command D. ls for listing the files. So we have our first file created here. Nice. Let's create a copy of the sample text file 1 as sample text file 2. Let's copy one more file as sample text file 3. ls for listing the files. Now we have 3 files here. So all these files we have created are in a working directory level. Clear command to clean the Git terminal. ls for listing the files. So out of these 3 files, I'm going to add only one file. Git add sample text file 1.txt. This add command basically moves the file from working directory to staging area. Let's verify that by checking the status. Git status. As you see, sample text file 1.txt is highlighted in green, and above line show it is ready to be committed, which means it is staged. Below are the 2 untracked files which are mentioned in the red. It means that these files are still in working directory and not staged. Clear enter. Check status again. I'm gonna add sample text file 2 as well, but we'll leave sample text file 3 as it is. Let's add git add sample text file 2.txt. Again, check the status. Now the sample text file 1 and 2 are staged, but the file 3 remains in the working directory. Clear enter. It is our time to do our first commit now. When we commit our files, these files will move from staging area to the local repository. Let's do git commit -m message sample text files to commit. Enter. Now our files has been committed. Let's check the status again. Git status. Only the sample text file 3 is shown as untracked files. ls for listing the files. Now we are gonna check the log of Git because it shows the history details, or you can say the entry details. So let's do the git log enter. This is the commit hash we discussed earlier, and current head branch is master. This is the author name and the date timestamp along with the comment we have placed while committing. ls for listing the files. Now I'm gonna add all the files which are remaining in the current directory. So for that, git add dot. This dot means that all the files in the current working directory will be added. Let's check the status now. Git status. You see sample text file 3 is being staged. Committing this change. Git commit -m adding sample file 3. Check git status again. Now working tree is clean. Now I'm gonna check the log again. Git log enter. Here we have 2 sha hash. These are the 2 changes which are saved in local repository. Clear enter. ls to list the files. I'm gonna use the vi editor to make changes in the sample text file 1.txt. Dot file updating. Save the changes. Now do git status again. This shows our file is updated. Clear. Git status again. Now here we are not going to use add command but the stage command to put our file to staging area. Let's stage this file. Git stage file name. Enter. Git status again. Nice. The file is staged. Now commit this change. Git commit -m file update. Enter. Git status. Now we have a clean working tree. Clear, enter. Git restore. Restore basically means when you bring down the file changes from staging area to working directory, or you can say unstaged files. ls for listing the files. I'm going to add it sample text file 2. So vi sample text file 2.txt. Updating file 2. Save it. Now check the status. Git status. Let's stage this file. Git stage sample text file 2.txt. Again check the status. File is staged. Now after adding the file to staging area, we realize that this file changes are not required at this moment. Then what do we do with this file? So we restore this file, meaning we unstage this file. Let's write git restore -- staged sample text file 2. Git status. File is unstaged now, but still the file changes are present in the current working directory. We can discard these changes as well. Let me show you by using the checkout command, which means that we are going to pull this file from the local repository, and whatever the version in the current directory will be replaced with the version which is present on the local repository. Okay, now git checkout -- sample text file 2.txt. Now if you check the status, it should be gone completely. Git status. Perfect. Clear, enter. Now we have restored the file completely. Let's move on. Suppose if A, B, C and D are the git commits and head is pointed to D. Now if we use the git reset command, then git reset will move the head and the branch reference to the specified commit. Which means if I want to discard the commits of C and D, which I no longer needed, then I can move the head and point it to B. So once the head is pointed to B, C and D will be lost. Let's see the git reset command in action. ls for listing the files. I'm gonna update sample text file 3 with the VI editor. Now here updating ... I'm going to save this file and check the status. Git status. File is modified. Let's stage this file with the help of git stage command. Git stage asterisk or star, which means all the files in the current directory will be staged. Git status again. As we can see, file is staged. Now let's commit this change. Git commit -m updating file 3. Check the status again now. Working tree is clean. Let me run the git log command. Enter. Here we can see the multiple SHA1 hash. I want this hash to be my new head and ignore the changes in the above hash. So git reset -- soft SHA hash, this one. Enter. Again do the git log. Bingo, the above commit is gone. As we have used the soft reset, so commit has been removed, but the file changes will remain in the staging area. So let's get rid of these changes by using the restore command. Git restore -- staged sample text file 3.txt. Enter. Git status. Now the file has been staged. Let's discard these changes completely. So I'm gonna check out the file from the local repository version. So git checkout -- sample text file 3.txt. Let's check the status again. Nice, changes are vanished now. We have three types of git resets: present in the soft, hard and mixed. Earlier we used to check git status for a particular file, whether that file is staged or not. But how we can know all the files present in the staging area? Git ls -files will tell us all the files present in the staging area. Let's see that in action. ls for listing the files. Now let's rename a file. mv sample text file 3 to javascript file.js. List the files again. These are the files in a working directory. Now I'm gonna list the staging files. Git ls -files. As you can see, stage files are sample text file 1, 2 and 3, whereas in working directory we have javascript file sample text file 1 and 2. So this is how we can know what are the particular files which are staged. Let me add the files git add dot. Let's check the status again. So file has been staged. As you can see, it is saying renamed. So Git is smart enough to recognize these things. Now I'm gonna check stage files again. Git ls-files. So as you can see, the JavaScript file now is staged. ls. Now I'm going to remove sample text file 2.txt. rm sample text file 2.txt. Let me add git add dot. Let's check the status again. Beautiful. We can see that the file has been deleted and the another file is renamed. Let's commit these changes. Git commit -m removed file and rename. Get a status. Our working tree is clean now. Let's move on. Git stash is a temporary place or shell where you can move your files from working directory or staging area so that you can quickly switch and work on something else as you were in middle of coding one thing and cannot commit your changes right now. And also you need to work on a new requirement. So in these kind of scenarios, stash becomes really handy. Let's see it in action. ls enter. I'm going to copy javascript file.js into typescript.js. ls again. I'm gonna copy one more TypeScript file as TypeScript2. Now ls again. I'm going to check the stage files also. So git ls-files. So TypeScript and TypeScript2 are not staged. Let's check the status. I'm going to add these two files. Check the status again. These two files are staged. At this particular point, you came to know that these changes should be on hold and we need to make some other changes. And later we need these changes again. So by using the stash, we can handle the situation. So I'm going to stash these changes. Git stash save TypeScript changes. Enter. Let me clear the terminal. Clear enter. To know how many stash do we have, we should use git stash list. Enter. Now we have this stash available. So our two TypeScript file changes are stored in this stash. So now if you check the status again, you won't see those changes. Let's do the git status. As you can see, there are no changes in the staging area and working tree is clean. Let's check the current directory, ls, and also in the current directory you don't have your changes. So as the changes are staged, I need to work on something else. So I'm going to edit the sample text file 1.txt. So here some new code changes updates. Save it, list the file again and check the status. Now this is the point where you need our stash changes. So now we need to bring back those changes. Let me first list the stash, git stash list. Then we need to apply this stash, git stash apply and the stash index number. Enter. Nice. We see the stash changes were already in a staged area, so it came back like that. Let's stage the sample text file 1 as well. Git stage asterisk, git status. All files are staged now. I'm going to commit these changes now. Git commit -m, changes updated and added. Clear enter. List the stash again. Git stash list. So we have utilized the stash already. Then we can remove this stash, right? We need to drop this stash. Git stash drop and this is the index of stash. Enter. Git stash list again. Now we can see that there is no stash available in the list. Right now we have done git stash apply and drop in 2 steps. We can achieve the same scenario by using git stash pop command. Let's see the example. ls copying sample text file 1 to sample text file 2. ls, let me add these files. Git add dot, check the status again. Now the sample text file 2 is staged. Let me stash these changes. Git stash save new file. clear enter. Let me stash the list. Git stash list. Stash is present. So let me check the status again. Git status. Our working tree is clean. Now let me apply the stash again, but this time we are going to use stash pop command, which will do both applying and dropping the stash. Let's do that. Git stash pop stash @0 index. Enter. As you see, the stash has been applied and the stash has been dropped. Check the stash list. There is no stashes available. Now let's commit these changes. Git commit -m pop changes test. Enter. Now we are done with the stash. Let's move on. Branches are the pointer to your main code base and allow you to create another copy of code base with all the code and history. Suppose if you are working on a new development item on version 3.0 and at the same time another developer fixing a bug for version 2.0. In these kind of scenarios, branching will help us to continue the work for both development and bug fix. Let's say this is your master branch. You create another new branch from this as new development, and another developer will create a branch called bug fixes for version 2. As soon as the bug fix is done, it will be merged into master. And later you can merge your new development branch into master once your development is done. Actually, the branching offers a way to work on a new feature without affecting the main code base. That's why the branches are the part of everyday development process. Let us understand this with an actual example. Let's go to command line. Currently we are on a master branch, as you can see here. How can we check how many branches do we have presently? Git branch enter. We have only master branch right now. Let's introduce one more branch. So to create a new branch, we need a command git branch and the name of the branch. In this case, new branch. Now check the branches again. Git branch enter. We have two branches. One is master, which is highlighted in green, meaning the master is active branch which we are working on. Let's switch the branch to new branch. Git checkout new branch enter. New branch is active now. Let's check how many staged files we have on this branch. Git ls-files enter. We have 5 files. Let's also check the git log. Git log enter. Here you can see that the head is pointed to new branch as well as master branch because there are no changes in both the branches. Clear the terminal. Git branch. Now list the files. I'm going to remove javascript file.js. rm javascript file.js enter. Now I'm going to add this. Git add dot. Let me check the status. Git status. As you can see that this file is deleted. Let me commit this. Git commit -m javascript file deleted. Enter. Let's check the status again. So after making changes in this branch, I'm going to move to the master branch. Git checkout master enter. Let me clear the terminal. Git branch. Now I'm going to merge the new branch into master. So git merge new branch enter. As you can see that javascript file.js showing 1-. So this is the deletion in the new branch, but when we merge into the master, these changes will move into the master as well. Let's check the status. So working tree is clean. Now let's check the log. Git log enter. So we are in the master branch, but if you see this commit, we have done this in new branch. So during the merge, not only the code but also the history will also merge. The another way of creating a new branch is git checkout -b and the new branch name. So here new branch 2 enter. So as you can see that new branch 2 has been created and also it has been checked out, which means that we switch to new branch 2 from master. List the files, ls. Now I'm gonna edit the sample text file too. So vi sample text file 2.txt, enter. So here I'm going to write new code changes. Let's save the file and stage it. Git stage asterisk. Now I'm gonna commit this. Git commit -m updates, enter. Now after making the changes into the new branch 2, I'm going to the master branch, and in master branch I'm going to make the changes on the exact same file and on the exact same line. Let me do that. Vi sample text file 2.txt, enter. Now here I'm going to make changes on the same line. Changes in master. Why am I doing the changes on the same line? You will get to know in a moment. Let me add and commit at the same time. Git commit -am changes in master, enter. Oh, double quotes, enter. Commit is done. Let's check the log. Git log, enter. As you can see, the head is pointed to master. I'm going to clear the terminal. Clear, enter. Git branch. Now the current branch is master, and I'm going to merge the new branch 2 into master. So git merge new branch 2, enter. Now wait, here we can see that auto merging has been done, but it failed in between and it has some conflict, right? So if you remember that we have made the changes on the same line, exact same line, then we end up with this issue, which means conflict. So you need to resolve this conflict manually. Let me go and fix this. Git status. Let me edit the sample text file too. Now if you see here, we have arrow symbol with head, which means that this arrow head and then the equal symbol. So whatever in between this, which is code changes in master, it means that this is present in the current branch, which was master in our case. And below the equal line and the arrowhead with new branch 2, this means that this is in the new branch 2. So these changes are on the same line. So we need to decide whether we need both the changes or we need one. So in this case, I'm going to keep both the lines. While resolving the conflict, we need to remove these extra lines. Let me remove it. Perfect. Now we can save this file and commit our changes now. Git commit -am conflicts fix, enter. So commit is done. Let me do the git log. As you can see, the head is pointed to master. So we had two changes after we have made the changes in new branch 2. So you can see that changes in master and conflict fix are the two commits we have done after the commit of new branch 2. So that's why the head is pointed to master, which is ahead of the new branch 2. So let me show you the file. ls cat to show the text, sample text file 2.txt, enter. Beautiful. File contains both the lines as expected. Let's clear the terminal. List the branches again. Git branch, enter. Now as we have utilized all the changes inside the new branch 2, so we can drop this branch. So git branch -d new branch 2, enter. Deleted branch. So let's check again. Git branch, enter. So the new branch 2 has been deleted. Alright, let's move on. Let's set up the remote repositories now. GitHub account setup. You can directly go to this link github.com, or you can go to Google and search GitHub. Now you can click the first link, github.com. GitHub is the most popular and widely used remote repository. So no doubt it is the #1 Git provider. And it's been trusted over 50 million developers and 3 million organizations with over 100 million repository. GitHub repo are being used by big as well as small organizations, and even the individuals are using it. So as you see here, Ford, Kubernetes, Spotify, and Adobe, and many other organizations are using it. Let's go to the top and click on the sign up button. We are redirected here. Now let's fill the information. For username, I'm going to type Sukoon code. For email address, let me type sukooncode@gmail.com. Enter the password. Now scroll down. So here for verifying your account, click verify. Or it says pick the spiral galaxy. So click on this one. I don't need any emails on announcement or updates. So uncheck this. If you need, you can check it, but I'm not going to need it. So now click on create account. As you see here, it is saying selected plan is free. So we are not going to pay anything to GitHub. Let's answer these questions to set up the account accordingly. What kind of work do you do mainly? So I'm a software engineer, so I'm gonna choose this one. Next question is how much programming experience do you have? So I have a lot of experience, so I'm gonna choose this one. What do you plan to use GitHub for? Create websites and GitHub pages, learn Git and GitHub, and host a project. Now here you fill your interested language and the frameworks. So let me write Java, JavaScript, Python, HTML and CSS as well, and last SQL. Let's click on this complete setup. Okay, so here it is asking please verify your email address, and GitHub already sent an email. So let's go to the Gmail, open this email, click on this, verify email address. Your email address is verified. This is your notification box. Let's click on this GitHub cat symbol and go to home. So we are on the home page now. It says create your first repository. So we are ready with the GitHub account setup now. Let's go and create the Bitbucket account setup now. You can directly go to the link bitbucket.org, or you can go to Google and search Bitbucket and click on first link bitbucket.org. Bitbucket is a product from Atlassian. It provides free Git repository for a team of 5 people. And here other products are mentioned of Atlassian. So let's go and sign up. Click on this sign in button and now click here sign up for an account. We are redirected to the sign up page. Here I'm gonna type my email address as sukoondeveloper@gmail.com and type the name Sukoon Developer, and now let's enter the password. Click on sign up now. Bitbucket sign up is finished and they have sent an email to verify our account. Let me go to my Gmail, sukoondeveloper@gmail.com ID. Click on this email and click on verify your email. It is asking to provide username. Let me copy the email ID and remove this @Gmail. Now it looks good. Click on continue. You can answer these questions or you can skip as well. I'm going to answer these questions. For first question you can say I have no experience. For second we have choose 1 to 5, so choose this one. And describe your role, so you can choose as a student and you are doing this for learning Git. Now submit it. So we are ready with the Bitbucket account setup now. Now let's go and do the configuration of Git remote repository for both GitHub and Bitbucket. Now that we have created accounts for GitHub and Bitbucket, it's time to do remote repository configurations. So first we will do the GitHub remote configurations. Let's go to GitHub homepage. So to create your first repository on GitHub, click on create repository. Let's put the Git tutorial as a repository name. In description, I'm gonna mention Git tutorial in detail. Scroll down and let's click on the create repository. We are redirected to this page. On this page, we have our Git URL for the Git tutorial repository. So let's copy this URL by clicking on this copy icon. Now let's go back to our CLI Git terminal. Here I'm going to add GitHub URL as remote repository. So git remote add GitHub, and here let's paste the copied URL. Now enter. So GitHub remote repository configuration is done. Let's go ahead and do the configuration for Bitbucket. Let's go to Bitbucket homepage. Here click on the create repository. Let me mention the project name as Git project and repository as Git tutorial. I want this repository to be public, So unchecking this and change this to no and this also to no, as I don't want readme or gitignore file as of now. Now click on the create repository. In this page we have few information, but now we only focus on the git URL of Bitbucket. Let's copy this URL. Now let's go back to the git terminal. Here let me add the Bitbucket URL as remote repository against Bitbucket name. So git remote add Bitbucket and paste the Bitbucket URL here. Now enter. So Bitbucket remote configuration is done. Let's verify these remote URL configurations. Git remote show GitHub. This is the name against which URL is mapped. Enter. Awesome. Our configuration URL is present here. Let's verify for the Bitbucket as well. Git remote show Bitbucket. Enter. Perfect. This is also present here. After configuring the remote repository URL, we need a way to upload our local repository content or files to remote repository. So for that, we have a command called git push. With the help of git push, we can transfer files from local repository to remote repository. In our case, it will be GitHub or Bitbucket. Important thing to notice about git push command is that you can only push committed files. While you upload your files to remote repository, you need to be very careful because it can overwrite the current files present in the remote repository. So let's understand the git push command with an actual example. Let's go to command line. So at first, let's upload our files from local repository to remote repository with the help of push command. Git push bitbucket master. So let's understand this command. Git push means uploading your file from local repository to remote repository. Bitbucket means that you are choosing a Bitbucket account which is mapped against this name. After this name we have a master. So master is the name of the branch. So you need to give the branch name here, given as master. Let's enter. Okay, now this is our first time to push our code into remote repository, so we need to provide the password for Bitbucket account. So let me enter the password. Now enter. Your files has been pushed. Go to Bitbucket website. Let me refresh this page. Bingo! We got our local files here. So as you see, we have our sample text file 1, 2 and JavaScript 2.js. Let me open this file 1. You can read these files. Click on this. Here you can see the git logs with all the information. You have author name, commit hash ID, message and date. Let's check the branches. Click on this. Right now we have only master branch. Let's go back to the command line. Let me clear the terminal. It's time to push our code into GitHub repository as well. It is exactly the same process as we did for the Bitbucket, only the name and the git URL will be different. So let's enter git push GitHub master. GitHub git URL is being mapped with this GitHub name. Let's enter. As you can see, the code has been pushed successfully. Let's go to the GitHub page and check whether it is really there or not. So let me refresh this page. Bingo, we got our files here. Let me open this one, sample text file 1. So here you can read the text as it is a text file. Let's go one step back to Git tutorial. Let me show you the branches. So here it has only master branch, and right here you can also check the commits. You can go through these all options and explore a bit more here. So this is the way of uploading your file from local repository to remote repository. Now, how do we download our code from remote repository to local repository? For that, we have a git pull command. Git pull command is basically to download the content from remote repository and update the local repository. To be more precise, it merges remote upstream changes into your local repository. Let's go to GitHub website. Here I'm gonna add a simple text file 1.txt. Click on edit here. Let me write updating directly on remote repo. Scroll down a little bit. In Git UI we have an option to directly commit our changes. So let's put our comment here. Updates. Click on commit changes. So changes are committed now. Now click on Git tutorial to go back. Our commit number increased from 10 to 11. Click here to check the git logs. this is the change we did 13 seconds ago with the username as Sukoon code. And these are the previous commits we did in a local repository as a developer1. Let's go back to Git command line, check the status, Git status. Here we are going to use pull command to download the latest changes. In this case, we have made the changes directly on the GitHub remote repository. So type git pull, and this is from the GitHub, so GitHub branch is master, enter. As you see here, one file changes and one insertion is there. List the files, ls, enter. Now here, let's check the content of the sample text file 1. So cat sample text file 1, enter. So we have our updated line, updating directly on the remote repo. Let's clear the terminal, clear, enter. Let me show you one more thing. I'm going to pull or download file from Bitbucket now. Let me try git pull Bitbucket master. It says updated already, right? So whatever the changes present in the Bitbucket remote repository is already present here. Let's check the status again. So our working tree is clean. Let's go to Bitbucket remote repository. Here we are going to edit sample text file 2. Click on edit. Let me type Bitbucket remote changes here. Now click on commit. Put your commit message here. Click on commit now. So our changes are committed. Let's go to git commit history. Click here on commits. As you see, the author name is Sukoon code. So this is the username present in the remote Bitbucket, and it takes default username as the author name. So let's go back to the Git terminal. Let's try to pull the latest changes from the Bitbucket here. Git pull Bitbucket master, enter. Now it is asking to merge the remote changes into local repo. So this is what the pull command does, right, in the background. So in this case, it is actually merging the remote changes into the local repository. So we have made our changes in local repository. That's why it is asking to merge. So let's save it. File is merged into the local repository, and it says one file has changed and one insertion is there. So let me list the files, ls, enter. We have made the changes in sample text file 2. So let's check the content, cat, file name, enter. So Bitbucket remote repo change is there. Git clone. Git clone command is a Git utility, and we use this git clone command to copy an existing remote repository into a local system. So to understand it better, let's take an actual example. Let's go to GitHub remote repository. Let's go to the Git profile page to create a new repository. Click on repositories, click on new button. So let's give the remote repository name as mobile app, and go to description. Here I'm gonna write detailed description, and I will leave other settings as it is, and scroll down. Now here click on create repository. Repo is created. Let me add a file here. Click on this. I'm gonna say this file as main.html, and let me paste some HTML and JavaScript code here. Alright, scroll down. Now put your comment, first commit for mobile app. Click on commit new file. So now we have a file here. To clone a repository, click on this code and click on copy icon. Now GitHub URL has been copied. Let's go to Git command line. We are already in a Git repository. Let's go to somewhere else and clone this repository. So cd ... to go one step back. Now do the git status here. So we don't have a Git repository here. Let me make a directory, mkdir new repo, enter. Now cd new repo. Here I'm going to clone the GitHub mobile app repo. Git clone -b, branch name is master. We are copying from the GitHub, so GitHub URL is there. Enter. We have successfully cloned mobile app here. Let's go inside this, ls, cd mobile app. Bingo, we got our Git repository here. Let me clear the terminal, clear, enter. List the files, ls, enter. We have only one file here as we expected. Let me copy main.html to app.js. Enter. ls again. Now we have two files. Let me commit these changes. So git commit -am new file changes. Enter. Oh, app.js is not staged yet. Let's do it. Git stage asterisk. Check the status again. As we see, file is staged. So let's commit it. Git commit -am new file changes. Git status again. Now our working tree is clean. Let me push these changes. Git push. Enter. Let's go back to the GitHub. Refresh the page. Now our changes are present. So we have seen the example of git clone command with GitHub. Now I want you to try the same example with Bitbucket. And if you need any help with that, then please comment or you can email as well. Let's move on. Git rebase. Git rebase is a process in which we combine a sequence of commits into a new base commit, which means that with the help of git rebase, we can maintain a clean working history. Clean working history will help us in understanding what changes has been done in a proper sequence, which ultimately will help us in finding the bugs in case of any error. Now let me take a pictorial example to get you the understanding what actually the rebase do. Suppose you have a master branch with C1 and C2 commit. Now from this master branch, we create a new branch called feature branch. Now in the feature branch, on top of C1 and C2 commit, we make a new commit called F3. After some time, someone else made a change in master branch called M3 commit. So when we merge the feature branch into the master, the M3 commit will come first, then F3 commit will come. In reality, the F3 has been committed before, and sequence will be distorted if we merge these two branches. But if you need a proper sequencing, then you need to rebase it. So what exactly happened after rebase is this. C1 commit will come, then C2 commit will come, then F3, then M3 commit. So this is what the proper sequencing is. Let's understand rebase with an actual example. Let's go to git command line. Here, first we will check how many branches we have. So git branch enter. We have active branch master, and this is the only branch we have now. Let me create a new branch called feature branch. So git branch feature enter. Let's check again. Git branch enter. We have two branches now. Let's check out the feature branch. Git checkout feature. Now we are in the feature branch, as you can see here. Let me show you git log as well. Git log enter. We have only two commits. Let me clear the terminal. List the files. I'm gonna copy main.html to panel.html. Enter. Now add the file. Git add dot. I'm gonna commit now. Git commit -m feature -01 commit. Enter. Changes are committed. Let's check the git log now. Now we have a new commit, feature 01 commit. Clear enter. List the files again. ls enter. I'm going to change the content of main.html. So vi main.html enter. Here I'm just changing the heading h2 to h3, and here let's say JavaScript changes updates. Save the file. List the files again. ls enter. Now I'm gonna stage all the files. Git stage asterisk enter. Now I'm gonna commit git commit -m text updates. Now let's check the log again. Git log enter. Here we can see that the latest commit is text updates, and after that feature 01 commit. So now we have made two changes in the feature branch. Let me move to master branch and commit one more change. Then we will do the rebase. So let me check out the master branch. Git checkout master. Now we are into master branch. Check the git log now. We have only two commits here. Let's make some changes. ls enter. Copy app.js into sidepan.js. Enter. Now list the files. ls enter. We have 3 files now. Let's add those. Git add dot. Oops, we have an error here. Let me do it again. Git add dot. Now commit the changes. Git commit -m master -01. Check the status again. Our working tree is clean now. Let me show you the git log again. Latest commit is added. Clear enter. Now wait. So what exactly we have done so far? We have made 2 commits in the feature branch and 1 in master branch. Now if we merge the feature branch into master, your feature branch changes will be the latest change, and which is not the case. So we need to ensure that we have a proper sequence history in which the operation has been performed. So for this particular reason, git rebase comes into picture to achieve the proper sequence of git log or history. So let's rebase the feature branch into master. Git rebase feature, enter. Now feature branch changes came into master with a proper sequence. Now are you excited to see the git log? Let's go there. Git log, enter. Nice. The master -01 is the latest commit we did in the master branch. And then the text updates commit we did, and then the feature 01. In this case, all the sequence are coming in a proper order. And you can also see the timestamp. This is at 2042, 2044, and then 2047. So commits after rebase are in sequence. Now clear the terminal. Let's check the status again. Now we are going to push this into GitHub. So git push, enter. Let's go to the GitHub and see our changes. Here our changes updated. Go to commits now. If you see the history here, this is what exactly the proper sequencing is. Why did we focus on the clean history, right? So in real time, the clean history or a proper sequence help us to identify the bugs and to roll back on a stable version of the application. So now we have understood the git rebase command. Let's move on. Git ignore is a special file to track all the files which needs to be ignored. There is no explicit git ignore command. Instead of that, we need to edit this .gitignore command and add the type or the extension in this file. Let's see this in action as it is very easy to understand with an actual example. Let's go to GitHub remote repository. We are working on mobile app right now, so choose this one. Click on mobile app. Here I'm going to add git ignore file. Click on add file, and the file name should be exactly like this, .gitignore. And inside the body of this file we have to mention what are the files which you need to ignore. So I'm going to ignore .log file, .class file, and .pdf file. Here the asterisk represents any name of the file, so it could be xyz.log file or anything. Let's commit this file. Scroll down. I will leave this command as it is. Create .ignore file. Now click on commit new file. Your file has been created. Click on it. So these are the 3 type of file which we are going to ignore. Let's go to git command line and pull this change. Git pull, enter. Check the files. ls, enter. Oh, where is our git ignore file? So as this is a .gitignore file, it is a hidden file. So let me show you. ls-a. Here we have our gitignore file. Now let me copy this app.js to app.log, and now copy the main.html to main.pdf. Copy this panel.html to panel.class. Alright. ls, enter. We can see our files are there. Let me add those files. Git add dot, enter. Now commit this change. Git commit -m git ignore testing. Now push to remote. Git push. Oh, it says everything up to date. Let me go to GitHub and check. Refresh this page. Oh, we don't have any change here, right? So what exactly happened here? Go back to command line. Now here type git ls-files, enter. Now if you see here, our log, pdf and class file has not been staged even. So that's why there is no change in the remote repository as well. This is how the git ignore file help us to ignore certain type of files which we don't need to push into the remote, but still we need those files to run our program. Now ls, enter. I'm gonna copy app.js to app2.js. Okay. Now add this git add dot, enter. Now I'm gonna commit git commit -m file edit, enter. Now push this change to remote, git push, enter. Change has been pushed now. Check the git ls-files. So app2.js has been staged. So it should be there in the GitHub repository now. Let's go there, refresh this page. We can see app.js and app2.js files are there. Let's move on. When you clone a remote repository on your local system, you cannot contribute back to the upstream or remote repository unless you are explicitly declared as a contributor. That's because your clone is separate instance of that project. And if you still want to contribute to this project, you can use the fork. Git fork. You might have heard this a lot of time, but still it is confusing, right? Actually, the fork is not a command but a concept. So we already know the git cloning concept. In git cloning, we copy a remote repository code into a local machine, right? And similarly, in the git fork, we copy someone else's original remote repository into our account remote repository. So it is kind of a remote to remote cloning, but between two different accounts. Once you have a remote copy of original repo, you can clone it into your local machine and update this code. Now you can push the changes to remote copy. From the remote repository, you can raise a pull request to the original repo. Original repo owner can approve or reject your pull request, or sometimes called as PR. Let's see the git fork in action to understand it better. Let's go to GitHub remote repository. Here I am searching a public repository which I need to fork with the username jjackl. Search in all GitHub. Now here we have our result, jjackl TypeScript.js project. Click on it. This project is under jjackl user and we are logged in as a Sukoon code user. So to fork this repo, we just need to click on this fork button. Click on this. Now GitHub is creating a copy of this repo into your account. Now copy has been created of this TypeScript.js project under your account. Let me copy the git URL and go to git command line. Okay, presently I am in D drive. Make a new directory mkdir repo. Now go inside cd repo. Let's clone the git repo here. Git clone, paste the URL, enter. Now go inside cd TypeScript.js project, enter. We are in the main branch now. Clear the terminal. Now I'm gonna list the files, ls, enter. We have only one file here. Now I'm gonna add my code and make this project better. So vi console.js. I'm gonna add console.log, making your code better. Save it, check the difference. Now stage the file, git stage star. Let's commit the changes, git commit -m, updated TypeScript. Let's push the code, git push, enter. Code has been pushed to remote repo. Let's go there, refresh this page. Check the content now. We have our code here. In order to merge this forked repo to original repo, we have to raise a pull request. So click here on this pull request. If you see it clearly, the arrow is towards the original repo. So the update will be merged from Sukoon code TypeScript.js project to Jack TypeScript.js project. As you see, we have only one line change. Let's click on this create pull request. Provide your comment here. Please approve, it has improved code. Finally, click on this create pull request. So PR is open now. Now let's go to our another account, jjackl user. We got one pull request. Click here, scroll down. Now this is the PR we need to review. Click on this. So we got an update from Sukoon code user. As it says, it has improved the code. Scroll down, click on this, merge pull request. You have three options to choose from here. I'm gonna choose default, create a merge commit. Click again. So no conflict as it has only one line chain. Click on confirm merge. Now our PR has been approved. Let's see the code now. Our updated code line is present here. So we have covered git fork end to end. This is good enough for a senior programmer to work on any project. I have covered all the necessary commands and concepts to give you a full understanding of it. Congratulations, you have completed this tutorial. So please subscribe, like and hit the bell icon to get the instant notification when I upload new tutorials. Thanks for watching the video. Have a wonderful week.